All right, the second conic section we're dealing with is kind of like a circle. It's like a smushed circle. It's called an ellipse or an oval. So if you notice the equation of the ellipse, it looks a lot like the equation of a circle. We have this x squared and we have this y squared. The only thing that's new is we have this change in x and this change in y in the denominator. And so what we have that because an ellipse has different size radii for your x and y. And so we call these major and minor axes. Your major axis is the long one. So for this one that I'm looking at, this is x is our major axis. This distance is the change in x. That's going to be our denominator. And then our minor axis is the y-axis because it is smaller. We literally just, whichever one's bigger is the major. This is the change in y. And those are the numbers we get in our equations. So when we talk about the vertex, we're talking about along the major axis, and the covertex is along the minor axis. And so we're going to do some practice problems, just writing the equations from the graph, just looking at it, plugging in the numbers. So this very first problem, we're just going to fill in the blank. So I have x over something squared plus y over something, we don't know what that is just yet, over something squared equals 1. And so to find out what those things are, I look at the center. This is the center, and I'm just going to say my change in x is this value right here, change in x. So that happens to be 2. So I'm going to put a 2 down there. Then I'm going to look at change in y. Here's change in y. And that happens to be bigger, so that is 3. So for this one, the y-axis is our major axis. So when it talks about the length of the major and minor axis, you can almost think of that as like asking you for those diameters. Whereas those numbers in the equation, those are our radius. So if we think about radius to diameter, we need 2 of that. So if you count all the way across vertically, the major axis, that major axis length is 6. It's 3 on top, 3 on bottom, because that's the radius. The length of the minor axis is the length all the way across at the center. So I have that change in x is 2. So I have 2 and 2 on each side, so that is 4. Then we've got the vertices. So again, the vertices are along the major axis. This vertice on top right here happens to be at 0, 2. This vertice here on bottom, that happens to be at 0, -2. Those are our vertices. Our covertices are the ones that are on the minor axis. So this is our minor axis covertice. That happens to be, oh, sorry, those are 3s, aren't they? I apologize. Those are 3s. I cannot count. So -3 and 3. The co-ones are the 2, so that's 2 boxes away. So that's 2, 0, and 0, -2. So those are our co-vertices. Again, they're on the minor axis. And then the only thing we have left to deal with is this thing about those focal points. Where is the focus? So for these ellipses, the equation for the focus is a squared minus b squared. And I use f instead of c, because otherwise I'll get it mixed up with some other things. But that focal point, so the focus point needs to stay inside the shape. A and B are the numbers, the change in x, the change in y. A is always denoted as your major axis one, so it's really not that important. We just, whichever one bigger minus a smaller square. So to find the focal point for this problem is going to be 3 squared minus 2 squared. That's going to be our focal space squared. So 9 minus 4 is 5, so the square root of 5 is our focus. So what that means is your focus is a distance, the square root of 5 from the center. So this happens to be centered at 0, 0. And so my focal point is the square root of 5 spaces away. So the square root of 5, 2 squared is 4, 3 squared is 9. So this is going to be a little bit more than 2. So I'm going to go a little bit more than 2 spaces, and that's going to be my focal point, and it's on the major axis. And then we're going to go down a little bit more than 2 spaces, and that is also our focal point. Then we're looking at writing these equations. So we're going to write these equations. The only difference between this one and the one we just talked about is these are not centered at 0, 0. So that means we have to introduce that x minus h, y minus k thing from our circles that we talked about. So the first thing we got to do is we got to identify this center. So the center looks like it's happening at -1, 2. So when we write the equation, it's going to be x plus 1 over something squared plus y minus 2 over something quantity squared equals 1. So that's where we start. We need to find our lengths, those separate radii. So I need to know what is that change in x right there. That change in x goes from -1 to 2, so that is a space of 3. And then I need to do the same thing on y. So the change on the y, so the change vertically. Looks like it's going from 2 to 4, so it's got a change of 2. So now if I wanted to find the focal points, I'm going to do 3 squared minus 2 squared, the exact same problem we just did in the previous one. The only difference is that square root of 5 is now oriented along the x, because this one, the major axis is horizontal, so it's the square root of 5, so roughly just barely more than 2 spaces. So it's going to be about there and there. And you'll notice that on these, the focal points, there's certain lengths that come up pretty routinely because they're all squares, and so there's only so many options we can get there. Sometimes we're going to see these equations written like this. Notice this format from the one we previously did. We had the parentheses including the denominator, and these do not. So when it's written like this, we just need to understand that the change in x here is the square root of 25, so it's 5. And the change in y right there is the square root of 81, so it's 9. The center of this thing, remember, it's x minus h and y minus k, so that center is -3, -1. And so we do the same thing that we've done in all of the other problems as far as finding the focal point, the vertices, all of that. Sometimes it's not written in the form that we like to graph from, and so we're going to have to do complete the square on it the exact same way we did complete the square with the circles. One of the things I see about this problem is I really very much prefer my x squared and my y squared to be positive. So what I'm going to do is I'm going to multiply this whole problem by a -1 to start out with. So I'm going to say 16y minus 52 equals 2x squared plus 8x plus y squared. The next thing I'm going to do to complete the square is I'm going to move that 16y right here. I'm going to move that to the other side with the y's. So I have -52. I'm going to leave it alone. I have 2x squared plus 8x. And then I have a plus y squared, and now it's going to be minus 16y. When we go to complete the square, what I'm going to need to do is I'm going to need to divide a 2 off there. So I have 2 parentheses, x squared. Now it's going to be a plus 4x when I divide that off, and I need to insert a blank right there. I need to say to myself, if this thing were a perfect square, what number do I put in the parentheses? And the way we figure that out is I'm going to take this 4 and I'm going to cut it in half. Half of 4 is 2. And 2 squared is 4. So I'm going to put a plus 4 in there. But when I do that, I need to say to myself, if I just put a plus 4 in this side of the equation, what did I really put there? Because it really means, if I multiply by 2, it means 8. So I put a total value of 8 on the one side. So now I'm going to put this plus 8 over here. I just kind of keep track of what all I'm actually adding to the equation. So I have 2x plus 2 quantity squared, because again, we're completing the square. And then I got to figure out what's going on the y side over here. So I need to say, what would I add over here to make this a perfect square? So again, we're going to cut 16 in half, and I get 8. So I want this thing to be a perfect square, y minus 8 quantity squared. But when I do that, this 8 squared is 64. I just added a 64 on the right-hand side of the equation. So it means I also have to add a 64 to the left-hand side. So I have 2 parentheses x plus 2 quantity squared plus y minus 8 quantity squared. And it equals, I'm going to add those things, 20. Looks like it's 20. Okay, so we're almost done. Remember, the equation of an ellipse is where it equals 1. So essentially what I'm doing is I'm going to divide this 20 off of everything. So I knew that I'm going to get 1 equals 2/20 is the same thing as 1/10. So it's going to be x plus 2 squared over 10 plus y minus 8 squared over 20. Now keep in mind that the change in x right here, the change in x is the square root of 10, and the change in y right here, change in y is the square root of 20. Keep in mind in this form that we did not include the squaring to cover that denominator. So that happens. It's fine. It's not always a friendly number, but we do know that the center is at -2/8, and we know that the change on x is a little bit more than 3, and the change on y is roughly 4.5 from the square roots of those numbers.